Saskatchewan Pulse Growers is striving to ensure at least one pulse crop option that is well adapted to local regions is available for every acre of arable land in Saskatchewan. Pulse crops provide many benefits to crop rotations, including nitrogen fixation, water use efficiency, and improvements to soil health. But when pea and lentil are too intensified in rotation, production issues such as Aphanomyces root rot can occur. Lengthening pea and lentil rotations is currently the only solution to help mitigate Aphanomyces root rot. Before introducing a new crop into an existing rotation, it is necessary to research the agronomic and environmental requirements for growing the crop, as well as the market opportunities and commodity pricing to ensure a positive economic return. SPG, co-funded through ADOPT, or Agriculture Demonstration of Practices and Technologies, a multi-site demonstration at 8 AgriArm locations across the province that showcased up to 10 different pulse crops. By demonstrating and introducing new and novel pulse crops, producers were able to see how these crops are, or are not, suited for different regions and determine if adding these crops into their rotation is economically feasible. At these sites, new and novel pulse crops such as lupin, cowpea, mung bean, and Adzuki bean were compared to minor acre pulse crops such as chickpea, Faba bean, soybean, dry bean, and fenugreek. These less familiar pulse crops were also compared against well-known and established pulse crops of pea and lentil. Despite not having the acreage of pea and lentil, minor acre pulse crops such as chickpea, Faba bean, soybean, dry bean, and fenugreek have proven that they can be successfully grown in Saskatchewan. These crops are essential for pulse crop diversity, but further development of markets and agronomic knowledge is needed to ensure their continued growth. Let's start with a review of chickpea. There are 2 types of chickpea grown in Saskatchewan, Desi and Kabuli. Kabuli account for most of the province's chickpea production. Chickpea is relatively heat tolerant and, due to its deep rooting ability, can utilize moisture further in the soil profile and offer an alternative to pea and lentil as a non-susceptible host of Aphanomyces root rot. Chickpea are best suited for the brown soil zone, but can also be successfully grown in areas of the dark brown soil zone. Growing outside of these regions is risky due to extended maturity and their need for a terminating drought, but also because they are susceptible to Ascochyta blight, which can be more severe under high moisture conditions. Faba bean, on the other hand, are best adapted to the moist areas of Saskatchewan and grow best under cooler growing conditions. They are a long season pulse crop with maturity around 110 to 120 days. Faba beans are more tolerant of saturated soils relative to pea or lentil and exhibit good partial resistance to Aphanomyces infection. They also have an exceptional nitrogen fixing ability, deriving up to 80% of nitrogen requirements through biological nitrogen fixation. Faba beans are high protein compared to peas, and they are used mainly as livestock feed currently, but there is increasingly uptake into fractionation. Soybean are best suited to high moisture and warm temperatures. They are well adapted to southeastern Saskatchewan. Their maturity ranges between 100 to 130 days, but beware, soybean are highly susceptible to frost damage, and the amount of frost-free days will determine crop success. Unlike other pulse crops, soybean offers growers additional weed control options, as most varieties have tolerance to herbicide actives such as glyphosate, glufosinate, or dicamba, depending on the variety. Soybean is sensitive to drought and requires timely moisture, particularly in late summer during pod fill. Unlike pea and lentil, they are a non-host crop for Aphanomyces root rot, but they are susceptible to iron deficiency chlorosis. There are multiple classes of dry beans grown in Saskatchewan, such as pinto, black, yellow, and navy. Like soybean, temperature and moisture drive dry bean production. Therefore, they are well suited to irrigation. However, there are Saskatchewan adapted dry bean varieties that are also suited to narrow row production and straight cutting under dry land conditions. Dry bean can reach maturity in 105 to 110 days, but are very sensitive to cold temperatures and can easily be damaged or killed by frost. Compared to other pulse crops, dry beans are not efficient nitrogen fixers and often require supplemental nitrogen fertilizer. On the plus side, many dry bean varieties have good resistance to Aphanomyces root rot. Finishing off the minor pulse crops with fenugreek. Fenugreek is a heat-tolerant pulse crop, but it is not resistant to severe drought. Fenugreek can fix its own nitrogen with the right strain of rhizobia, but no commercial inoculants currently exist in Saskatchewan. Research is ongoing to develop an inoculant for fenugreek production. Like many other minor pulse crops, fenugreek is considered a non-host crop for Aphanomyces root rot. Fenugreek offers a range of unique end uses, including use as a herb, spice, flavoring vegetable, animal feed, medicinal, pharmaceutical, health food ingredient, and industrial applications. Novel pulse crops such as lupin, mung, and Adzuki bean, and cowpea have potential adaptation for Saskatchewan growers to expand their pulse crop diversity, but market access and environmentally suited varieties currently limit the adoption of these crops. Ongoing research is underway, but don't expect these novel pulse crops to hit wide-scale field adoption too soon. Of these novel pulse crops, lupin is likely the furthest along the path towards Saskatchewan production. Lupin is a moisture-loving pulse crop best suited to black and dark brown soil zones. It also prefers growing in low pH soils and is sensitive to soils above a pH of 7.2. Varieties currently being evaluated in Western Canada have also shown to be resistant to Aphanomyces root rot in greenhouse studies. The edible species that are being considered in Western Canada are sweet white lupin and narrow-leaved blue lupin. Narrow-leaved blue lupin has a similar growth cycle to Faba bean, requiring 110 to 120 frost-free days. White lupin has a similar growth cycle to soybeans, with a longer maturity of 130 days or more. Lupin has been used as a soybean feed ingredient substitute and has potential for bioindustrial applications as well as human consumption. Due to its high protein levels and very little starch, lupin is appealing for fractionators struggling to find a market for starch byproducts. With sufficient heat units, cowpea matures within 90 to 120 days, more similar to soybean and mung bean. This warm season pulse crop is also highly drought tolerant and performs best in sandy soils. The majority of cowpea production currently occurs in Africa. Also, similar to soybean and mung bean, cowpea is highly sensitive to cool temperatures and frost. Establishment in Saskatchewan will be dependent on frost-free days and heat units during the growing season. Known as green gram internationally, this novel pulse crop might be most familiar to you as bean sprouts. Mung beans have a high-quality protein profile, and among all the pulses, have the highest digestibility. Their neutral flavor profile also make them well-suited as an ingredient in plant-based food products. As a warm season legume crop, mung bean are well adapted to similar growing regions as soybean or dry bean. Mung bean are relatively drought tolerant and do not tolerate compacted or waterlogged soils. They are a non-host crop for Aphanomyces root rot, but some varieties are highly susceptible to bacterial blight. Adzuki bean share many of the same agronomic characteristics as mung bean, but instead, they are known for their red seed color. Considered the second most important legume crop grown in Japan, Adzuki bean is grown for its sweet, nutty flavor and is used primarily as a confectionery ingredient in Asian desserts. Tepary beans are common to the southwest United States and Mexico. While they don't have the disease resistance currently needed to survive in Saskatchewan, they are able to thrive in marginal growing environments due to their inherent drought and heat tolerance. Although Tepary beans were not featured in any of the novel pulse crop showcase sites in 2022, they are worth mentioning because they are currently used in Saskatchewan pulse breeding programs, and they may hold genetic clues to improving stress tolerance in our common dry bean varieties. The pulse crop industry is always evolving, and these minor and novel pulse crops have great potential to diversify Saskatchewan rotations. Agronomic research and market development efforts will continue to ensure grower success when introducing new options on the farm. You can learn more about research being done on these and other pulse crops at saspulse.com.